Thank you. All right, so 71A, irrational numbers. So first of all, in this chapter, specific page, what we're trying to do is that we are trying to understand how do we calculate and expand and simplify a irrational number. So let's take a look at the definition of rational and irrational number, Alfred. So rational number is a real number that can be expressed as an integer or quotient of integers. So these ones you're pretty familiar with, right? 4, 0, -3, and so on and so forth. What about
Yeah.
irrational numbers? Irrational numbers are a real number that cannot be expressed as an integer or quotient of integers, including infinite non-repeating decimals. So do you know what an infinite non-repeating decimals is?
It's like um 3 point
Yeah,
something something
something
something and it
like,
goes
1.23567,
uh
1, 2, 3, something like that. It's like very you
long.
have infinite, and then it's not repeating. Some of the repeating ones, for example, 1/3, right? 2/3, something like that. That's repetitive. It's like 0.666 or 0.33333. But these are all called real numbers. All right, let's take a look at an example over here. We have √3 times bracket 2 √6 plus √3, and this is the operation over here. So all you need to do is you just actually multiplying the √3 into the bracket and multiply √3 into the √3 as well. Do you know how we get the 3 over here?
Yeah.
Okay,
So
so
√3 times √3 is just 3.
okay, perfect. Do you know how we get this the 6 over here?
Yeah, because like you get the √3 and the √3 and you multiply them and you get 3 and then you do that to the 2 and then you get 3 times 2 equals 6.
Okay, perfect. So let's do this question over here together. Okay? All
Okay.
right. First of all, the 6, where does the 6 come from? The 6 come from the 3 √2 times the √2, right? So almost it's like you are calculating like this, right? So use the 3 √2, multiply the √2, minus 3 √2 times the 2 √3. And then once you're done with this number, you use the √3 times the √2, and then √3 times the 2 √3.
It's like foil.
What is it?
Foil.
Sorry, I'm not understanding what FOIL means.
Oh, it's like the method I learned in school.
Okay,
It's
perfect.
like
So yeah, so you use this one and you use this one. Okay, any questions for this page?
uh no.
Pretty straightforward, right? Okay, so if that's the stuff, what we can do is that we can move on to, do you mind moving on to 72?
Yeah, we could do that.
Okay, so let's move on to 72. All right, with the example over here, I want you to try question number 4. All right, so let's take a little example over here. √7
Mhm.
plus 2 √3 and √7 minus √3, 2 √3. So note that these two number, they are the same, right? Any questions?
No.
Okay, and also this number and this number, they're the same. So essentially what happened is that, Alfred, do you remember this formula?
Yeah.
Okay.
And then I equals
And
one.
what is this formula called again?
Difference of squares?
Very good, because it really just looks like the difference of square, right? So when you
Uh,
expand it, it will be x squared minus y squared. Okay, so
yeah.
very similar to this. So this actually gives us some understanding of why we have √7 to the power of 2 and 2 √3 to the power of 2, right? So very easily we can just get 7 minus 2 √3. Make sure that you will square the 2 first and then get the 3. So essentially what happened is that this 2 to the power of 2 will be 4, and times √3 times √3, it'll be 3, right? So that's how you get the 12 over here. Okay? All right. And then last but not least, you will get 7 minus 12, which is just -5.
-5.
Okay, perfect, buddy. All right. With that, can you try number 5? This one is a little bit tricky. Just
Mhm.
do you get ready to kind of change the sign somewhere? Okay. So can you try this without looking at the answers first?
Yes.
Okay, let's try and see what you got.
I got -20.
Okay, perfect. So this is the right answer. Good job. All right. So you were able to handle this page, right?
Yes.
Perfect, but okay, with that being said, let's try 73. Any questions for 72? So again, for the B side, it's very similar. It's a little bit more complicated, but it's very similar, right? For example, on the B side, you have something that looks like this. If you can actually go to 72B,
Okay.
72B, yeah, 72B, and why don't you try question number 9?
9.
Yeah, question number 9. There are a couple ways to do question number 9, okay? So
Yeah.
first way that you're doing question number 9 is that you can group the first two numbers together and then treat the last number as it is. Or, right, this is one way. Or you can group the first number and then the second and third number. But just mind you that because this is negative here, you will need to change the sign inside. So essentially it will become something that looks like this.
Um.
Okay. Something like this. Okay. But the idea is very similar. You just use this one minus that one. Okay. All right. Let's try it out and then tell me the answer later.
Wait, do I have to use that way?
It doesn't matter. You can actually follow, just use the first two numbers, root 3
What
and
if
2.
what if I like take the entire thing and just multiply it by itself like I
You can do
expanded?
that, but then you will get 9 terms. All right. So
Uh,
what you're trying to say is that, okay, you're trying to do this.
yeah.
Right? And then you expand it like that. So watch this, okay? If I'm, really drawing the line over here, I'm gonna do one, count it, okay? Two, three, right? And then basically this is done, and then I'll do one, two, three, and that's already six. It means six
Yeah.
operation. Last but not least, I'll do one, two, three, and that's 9 operation. Do you prefer to do 9 operations instead of you just using a formula of perfect square and basically just doing 3 operations here, whichever you prefer? There's a
I'll take the 9.
you're okay with the 9?
Yeah.
Okay, you know what? But try the 9 first and then try the 3 operation here.
Okay.
Okay. So I'll tell you this. Whenever we're doing equations, especially with multiple terms like this, always go for the easier method of,
Yeah.
putting the equations into the concept of using formula. There's a reason why we use formula, right? All roads lead
Yeah.
home, but we wanted to have the shortest route. Okay, so you keep going. Okay.
Okay.
All right.
Wait for that and for feedback.
Okay, so for Alan, we have Josh, uh, Vera, and I believe Thomas. Yes,
My good one.
yes. It's okay. Home is here.
Yes.
Ask him if he's coming today.
Of course, remember he said, but I will double check. Yes.
All right, so what you got?
I got 11 minus 2 root 6 minus plus 6 root 2 minus 4 root 3.
Okay, you're good, bud. Okay, so let's go to 73A.
93A.
Okay,
Yeah, by the way, when I was doing the thing, I realized that the difference of squares thing was a bit easier.
difference of square, right?
Yeah.
Yeah, there we go. So for this page, specifically, we have to use difference of square. Again, you can use whatever you prefer over here, right? Just like what you were saying over here, right? But
Mhm.
alternatively, this example is trying to teach us, okay, I can group the first two since I have the same number here. And then
Yeah.
because I have a difference, this is plus, this is minus, this actually perfectly matches our formula of a difference of square. And last number is root 5, so we can actually just use this. Okay. Okay, so can you try question number 3 and see how are you going to rearrange things? Okay.
Good.
Mhm.
Yeah.
So 74A. All right. So we call this rationalize. Do you know what the word rationalize means?
Make it like rational.
So basically, I would say is that it's called the D irrational number at the denominator. So you're basically getting rid of the denominator, well, getting rid of the irrational number at the denominator stage. So as you can see from the example over here, it says note to rationalize the denominator means to perform an operation that will eliminate the radical sign from the denominator, right? So it's called the radical at the denominator stage. All right, so from the example over here, what can you see?
Um, so they just eliminated it by like turning the root 5, basically squaring it into a +5, and then they multiplied the root 5 into the root 3, giving you root 15.
Okay, so essential idea, I like your answer, but essential idea was that we see any radical signs underneath. For example, we have root 7, root 5, root 3. In
Yeah.
this case, it's going to be root 6, so on and so forth. So all we need to do is that because we know the attribute of fraction, right? Let's say we have a question mark, question mark, question mark, prime. So in order for me to change anything, eliminate anything, I have to multiply the same number at the bottom, okay? And also multiply the same number at the top, which means that in all these cases, as you can see that this is root 5, in order for us to change that root 5 into 5, we have to multiply exact root 5 as well. Same thing with the numerator root 5 as well, okay? Okay, very similar with the others. Let me ask you this, Alfred. In terms of 3 root 2, why don't we multiply the whole thing by 3 root 2? Instead of
Because
that, we only multiply by root 2.
yeah, because like if you did the 3 root 2, you'd have to like factor it, like it'll go to the numerator as well, and then we will just reduce it. So that's just extra work.
Perfect. So one thing is that because it's just, the number on the side is getting a little bit more complicated, our goal is just to change all the radicals into, normal number, right? So
Hmm.
in this case, just focus on the radicals, the root 2 in this case. So for question number 4, if I see that root 6, 3 root 2 over here, all I need to do is multiply the bottom and also multiply the top by root 2. And on the bottom, 3 root 2 times root 2 will be 6. Very easy because root 2 times root 2 will be 2. And 3 times that 2 will be 6. Okay. On the top, root 6 times root 2 will be root 12. But however, this root 12, back in level I, we learned about this as well, this is what? 4 times 3, right? And
Hmm.
basically it will be root 4 times root 3. And I will get 2 times root 3. That's where we get the 2 root 3 from. And then the 2
Yeah,
is reduced with the 6. All right. So
and
then
then
I get root
root
3.
3 over 3. That's
Good.
all that's left.
Perfect. All right. Can you try question number 5?
5.
Yeah.
Okay.
And give me an answer for question number 5, please. Thank you. Okay, so you got root 5 over 10.
Yeah, for number
Okay.
5.
All right. Looks good. Hmm. Okay. So let's see. Root 5 over 10. All right, good. 74B, which is the last page here. Okay, so this page, before we're just talking about the numerator and denominator. Right now, we have something that's a little bit more complicated, as we have other operations involving it. We have addition and subtraction with two fractions. Okay, so let's take a look at the example first. So we have root 3 plus 2 root 3. So first of all, we have to rationalize this one, right? Once we rationalize it, it becomes 2 root 3 over 3. And then how did you add the root 3 to the 2 root 3 over 3? We have to find the LCM. In this case, the LCM becomes 3 root 3 plus 2 root 3 over 3, right? So the top 3 root 3 plus the 2 root 3 will give you the 5 root 3. Okay, so don't forget that anytime that we see a fraction, most
Yeah.
likely we're trying to find the LCM, and that's how you combine everything together. So with that being said, if you can, I'll give you a harder one. Let's try number 4 first, and then try number 6. Okay.
Okay.
Okay. Okay. So what's the first one?
Uh, First one I got negative root 2 over 2.
Negative 2 root. Okay, good. Very nice. Number 6.
On the second one, I got 5 root 6
6.
over 6.
Oh, I think there might be a reducing problem.
Maybe.
Yes, I think there might be a reducing problem. Can you see, because the denominator should be 12. Can you see the where you had the problem?
Hmm.
Okay.
Okay.